All right, guys. This week should be pretty not too bad. Okay, we're talking about functions, and it's a lot of substituting. Okay, so find the output of f when the input t is 7. So functions have inputs and outputs. We talked about that last week. So the input is 7. What does that mean? That means we're going to substitute, 7 in for t. So 2t minus 3 becomes 7 minus 3, which is 14 minus 3, which is 11. Let me show you. Ta-da! All right. Find the, now the same thing, only with the graph. Find the output when the input is -1. So on the x-axis, we go to -1, which is here, and we go up, 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 up to the graph, and we see what the y value is. Looks like it's 3. So at -1, the graph has a y value, the function has a y value of 3. 2 for 2. Okay, so hopefully you're like, oh, Mr. Field, that was easy. Okay, now guess what? This one is not too bad either. Linear, nonlinear. So linear has slope. No, and nonlinear is no slope. So linear is like that. Straight lines. Nonlinear. Curves. You know? Oh, I keep drawing the same curve. So that's the linear side, that's the non-linear side. So if we have a table, let's check for slope. Subtract 1, subtract 1. On the other side, we would add 4 and add 4. And then this adds 6, and this adds, oh, that's subtract 1. So you can see adding 6 and subtracting 1, where here, where previously we're adding only 4, subtracting 1 is not a constant rate of change. So the answer here is no. Let's do another one. Oh, and here's a graph. Is this linear? Is it a straight line? No. Let's do one more. All right, what are we going to do? Table, we're going to find the slope. So find the change between the y coordinates. 6. 6. Okay, so let's see. We were looking for a common ratio. So we're changing by 1, 3, and 2, and 3, 6, and 6. So what I can do is I can put my y over x in each case. Oh, and I should get equivalent fractions. And if I don't, then I know nonlinear. 3 over 1 is 3. 6 over 3 is 2. And 6 over 2 is 3. So this one messes it all up. If that one was also 3, we would say linear. But we're going to say, I have messed up. All right. They're all 3. Have I messed up? Okay, the change from -6 to 3 is 9. How could you guys let me do that? That's 9, which makes it 3, which makes it them all 3. And so we're going to say yes. All right, let's do the last one here. So now here is this one is a little tricky. We're going to interpret, but it's good to have this one because look at all the words, and we have applications, real life, getting into the math, and we all know that's important. So let's read this. A doctor observes a graph that shows the electrical activity in volts of the heart of a patient over a period of time in seconds. Each spike corresponds to 1 heartbeat. The doctor needs to calculate the heart rate of the patient in beats per minute. What is the heart rate of this patient? What is the heart rate of this patient? Well, I'm looking at it, and I can see that there's T is in seconds, and then this is, what is the y-axis? Volts. So every 1 second, there's some volts there. So looks like the patient's heart is beating every second. And so how many beats would that be in a minute? How many seconds are in a minute? Well, it's a tough one, but there's 60 seconds in 1 minute. So if the person's heart is beating every second, then that means there's 60 beats in 1 minute. I had to reason that one out. Could you? All right, now here's another one. Okay, complete the following sentences based on a graph of the function. So we've learned different things about graphs, slopes, intercepts, and all of that. Now we're just gonna put it together. So the graph, this is the graph of a nonlinear, as you can see. The y-intercept is -6. The x-intercepts, it has 2. One at 2 and one at 6. The greatest value of y is, so this one, when we trace the graph, it has a high point right here. And what's the y value? 2. And when does that value of 2 occur? It occurs when x is 4. For x between 2, x of 2, and 6, the function is, so between 2 and 6, you see how the function is up here? Well, look at the y values. The thing about them is they're positive. Okay, so we're going to say the y values are greater than or equal to 0. Got it again. All right, so go ahead, give it your best shot. Put your questions in the organizer, and we'll get started.